Joining me now is Martin Ward. He's a professor of astronomy at Durham University in the United Kingdom. Thank you for being with us on France 24 tonight. Now, talk me through this, if you will. Stephen Hawking didn't discover black holes or quantum physics, did he? But he did very much broaden our understanding of them.
Yes, that's absolutely correct. The concept of black holes goes back several centuries, actually, but that was a mathematical concept rather than a physical concept. And I'm an observational astronomer, so I try to find black holes and study them with the Hubble telescope. But what Stephen did was looked into the theory behind black holes. There's a bit of a misconception. They're actually very simple things. They've only got three properties. They've got mass or weight, they've got spin, rotation, and charge, positive or negative, and that's it. But what Stephen discovered is they're a bit more complicated than that. And they can, in fact, begin to gradually disappear with time, the so-called Hawking radiation.
Now, I understand that you met Professor Hawking. Dare I ask, what kind of conversation did you have?
Well, it was a bit tricky. I met him when I was a young researcher in Cambridge, many decades ago now. And at that point, he was able to speak, but his speech was very slurred. And so I don't know whether you know what it's like when you're in a party and things are very loud and you only catch every sort of second or third word. It's a bit tricky. You have to sort of make the most of what you can get. And that was a bit what I felt like. It was at a reception. And so we didn't discuss science, but I mean, I'm just glad that I had an opportunity to meet him at least once. Now, and of course, his work I'm familiar with.
Now, right, of course, and he was such a well-known physician, wasn't he? Why do you think he never won the Nobel Prize?
That's an interesting one, and I think the answer is pretty simple, actually. Certainly nothing to do with intellectual ability. It's just that the Nobel Prize is awarded when something has been proved by observation, by experiment. And this Hawking radiation is pretty weird stuff. It's to do with quantum mechanics and gravity, which I don't think I can explain in 10 seconds or even 10 years, perhaps. Anyway, you have to observe something. And the problem with Hawking radiation is that it has not yet been observed. It's possible in the Hadron Collider, the Large Hadron Collider, eventually there may be proof, but very sadly, Nobel Prizes can't be awarded posthumously.
Yes, that's true. And rolling television news isn't made for discussing quantum physics, is it? I'm afraid.
Not really.
I wanted to ask you a bit more about his legacy, because he famously said, didn't he, that he wanted people to buy his books in airports. This wasn't someone who wrote dusty papers. Well, he did, but he didn't just want his papers to be read by professors and other scientists. He really wanted to give ordinary people an understanding of these very, very complex issues. And that in itself was a real talent, wasn't it?
It's actually no secret, because he said himself that one of the reasons he wrote The Brief History of Time, that sold 10 million copies, was financial. You don't get a lot of money for getting gold medals and awards. I suppose you could melt them down, but frankly, he needed some money. And so writing a best-selling book was one route to this. And indeed, it was a best-selling book, but it's often said it's the most bought book that has never been read, because it's quite a task to read it. I don't know whether you have, but it's not an easy read. But it's the sort of thing people like to have on their shelves. Also, just to say another thing, he was a popularizer, not just that book, but other books. And I think one of the tributes to that side of his career is that various undergraduates and students in Cambridge have said how they were inspired by his writings. And these students are often history students or linguistic students or politics students. They're not scientists. So he did reach out. And it wasn't, of course, just black holes. He had his own views about alien life, which were quite interesting, actually.
Yes, and artificial intelligence and lots of the major issues of the day. He also was in favour of the human race moving to another planet one day.
Absolutely. He was very keen on this, because he said that the possibility for disaster, whether it's climate change, being hit by a huge rock from space, or a disease, he thought that was a real problem. And if we could manage to colonize, say, Mars or even beyond, that would give us an Earth and a spare in case the Earth got destroyed. But he was also worried about extraterrestrial life. He thought that if we were to be contacted, we should hear a radio signal. Maybe we shouldn't reply, because he was a bit worried they might come and exploit us, as we did, of course, many centuries ago with the South American Indians. And not everybody agreed with that, but that was one of his concerns, is that we shouldn't necessarily respond to any signals.
And he talked about wanting to know the mind of God. He referred to God a lot when he spoke. Do you think, like Einstein and like many scientists, in fact, he had these kind of ambiguous religious beliefs, or he had some ambiguity about the origins of the universe?
I think he did. I think sometimes he used the word God to be provocative as a sort of metaphor, really, for understanding everything. I'm not sure he really meant it in the sort of deity sense. By the way, just as a cosmic coincidence, I don't know whether people realise, today is also the birthday of Albert Einstein. But that's a cosmic coincidence. It's only 1 in 365 chance, but there you go. Stephen's death, Einstein's birth.
Very interesting and very spooky. Martin Ward, thank you very much indeed.